into Docker, pretty much. We looked into Docker. Um, Dominic did a lot of labs. Do we have any question? Any question? Anything from that last week? Anything you? Anything we are missing? Anything you feel like? Oh, hey, I would like a little bit more explanation on this before we enter into Kubernetes proper.
Any questions, guys? Any question from last week? Anything you are not clear about? Anything you would like me to explain more? Okay, all right. So I can start today. Can start for today. Okay, so today we're going to look into Kubernetes. What we're going to do today, we're going to look at, hey, what is Kubernetes? What it's all about? What's the whole idea? Why do we need Kubernetes, right? Why do we even need Kubernetes? What's the whole force about Kubernetes? What we're going to look at, imperative and declarative approach. That's what we're going to look at. And I believe at the end of the class today, we should be able to understand what Kubernetes is. We should be able to understand what a pod is. We should be able to understand what some of the resources of Kubernetes are. So starting off today, we're looking at Kubernetes. So what is Kubernetes? Kubernetes is basically an open source software designed for container orchestration. Over the last 2 weeks, we'll be looking at containers, and we say, okay, hey, if you did some of the labs that we did, we'll show you, say, okay, some of the labs, you say that one of the things you do when you start a container, it's the container comes up, then it shuts down, right? Basically comes up and shuts down. Or if you're doing the batch mode, it basically runs on its own. So what happens when the container runs out of service? What happens when the service is not available? How do you orchestrate those things? How do you manage them? The main job of Kubernetes is to manage containers, right? So it takes what they call a declarative approach. I'm very careful about saying this because you can deploy with imperative approach, but take what's a declarative approach whereby you define what your infrastructure is. For example, you can say, hey, I want my cluster, I want my application to be available on every node. I know you don't know what a node is, but that's what on the beauty of Kubernetes. So I can write out my manifest file, what we call the YAML file, with the Kubernetes manifest file, and basically hand it over to you, and you run it and you deploy your application. That's one of the beauty of Kubernetes. Kubernetes is actually very, very robust. It is well accepted. To put that into context, Kubernetes started in Google. They called it bug, right? Before they finally open sourced it. That's Kubernetes. And which about Kubernetes can work. Kubernetes basically right now we can consider the language of the internet because you have multiple applications, multiple microservices applications, even AI applications are being hosted on Kubernetes. Right. So again, back to what I said the first time I started this session. I said, okay, it's good to know these things. Don't try to cram it. Again, today we're going to introduce a lot of command, but what I would like you to know is to try to understand the basics. Because if you understand the basics, you can use all the language module of your choice to figure out what the code looks like, right? You can, if you question it and it's telling you, okay, hey, this is the error, this is what it's like, you actually know what you're looking for. Okay. All right, so reading up a few things on this slide, say Kubernetes, key features of Kubernetes is deployment and replication of containers. That's the beauty of Kubernetes. So you can scale in and you can scale out of containers. You guys remember what we mean by scaling and scaling out? Scaling, hey, scaling when you're doing vertical or horizontal scaling. Vertical scaling basically say, hey, you're adding more CPU and memory on top of your containers. On top of, in this case, Kubernetes is calling it pods. Horizontal scaling means you're adding more instances, right? When you're adding more instances, that becomes horizontal scaling, right? You can configure load balancing, right? With containers, they're a very beautiful thing. You can do what's called rolling upgrades of nodes. So, for example, you need to update your node. You can do configure rolling updates, right? To say, hey, I don't want, what is rolling updates? I don't want all my nodes to be updated at the same time. How many of us have worked in a server environment whereby you need to update a particular application, the whole thing goes down? With Kubernetes, you can do something like, hey, I want to update this particular node so that as I'm updating this particular node, this application will still available. That's the beauty. That's the beauty of Kubernetes, right? Resilient and automated scaling of failed containers. So you want a solution whereby, hey, Kubernetes has this one big feature that I actually love about it. I remember when I was learning this during COVID. So one of the things I love about Kubernetes is the fact that anything should go down. If you're running a pod, right? I'll explain what a pod is. If you're running an application which is inside a container in a pod, if you're running it and the application is not available, the Kubernetes service, which is the kube scheduler, I'm going to explain that soon, very soon. We'll keep trying to restart that pod, try to restart the container. So that's why of the beauty of Kubernetes. They say basically Kubernetes is self-healing. Yes, it's Kubernetes self-healing in the sense that it can heal itself. If you run into issues, it can heal itself. It can self-heal. It can try to fix itself. Let me just put it like that. It can try to fix itself. You can expose your services outside of your cluster, right? For example, Kubernetes helps you use the option to say, hey, okay, I want to expose this Kubernetes outside of my cluster. I want to expose it to the internet. For example, now imagine I build this wonderful application, call it non-so app, and this app is actually inside my system, and it hasn't ever gone over to the internet. This app is inside my system, inside my cluster. How will you access it? How will you even check the application, right? Kubernetes gives you the option to be able to expose that application over to the internet, right? Any questions? So this is any questions, guys? Before I start digging deep. Okay, no questions. This is basically Kubernetes architecture. Very beautiful thing, right? This guy explains what Kubernetes is all about. If you understand this guy, you actually understand Kubernetes. So what is this? Kubernetes works in a very funny way. It's using the REST API technology. So you have in terms that whereby you have kubectl, use it to make query to your API server. So Kubernetes basically have two things. It has the API server and it has the worker node. API server and worker nodes. What are they? API server basically means say, hey, API server is the one that whereby you is basically the one that receive all requests. So the entry point to Kubernetes cluster is your API server, right? If I want to access a Kubernetes service, I'm reaching in through the API server. Inside the API server now has things like the kube control manager, the kube scheduler, the ingress controller, if you have ingress configure, the kube services, the HCD, the kubelet, the kube proxy that are basically inside the worker nodes. I'm going to take it bit by bit. I don't want to rush it. So, okay, this is talking about nodes. Let me narrow down on the API server. Okay, Solomon, right. It's also recorded, so you can also watch it back if you miss anything, or you can ask questions when you're back. So the API server has what we call the kube control manager. What's the function of the kube control manager? Control manager is basically, hey, its job is to control all the other resources of your Kubernetes cluster. So the kube control manager controls all the worker nodes, all these nodes. So all these guys are nodes. What are nodes? Nodes are basically VMs, servers. So your resources, your containers are hosted in a node. So the kube control manager is basically a resource that is used to manage those nodes, right? For example, now, hey, I want to host a container named an application named pod, right? You name Favor. Let me use Favor for example. Favor application. If I want to host it, I'm reach the API server. I say, hey, API server. Okay, this is my manifest file. I want to host it on a node. I want to host it on this Kubernetes. The kube control manager is the one I'm going to check. Okay, do I even have any node available? You have any space in these nodes? So once it checks those, I finish checking it. The next thing it is going to do is going to hand it over to what we call the kube scheduler. The kube scheduler. These names are become confusing, but I just want you guys to I want you to understand it. So don't worry too much. Kube scheduler is just going to say, hey, okay, hey, Favor app, just like Favor defined there in his manifest files, which is basically a set of YAML files. Favor app will be in what? In node 1, in node 2, in node 3. That's what Favor app will do, right? That's what the kube API, the kube scheduler will do. The next thing I want to talk about is the etcd server. What etcd server? Etcd server is just like a database. Just a database. It's basically, they call it document database. But what does it do? It keeps record of where your various applications are stored. Where are they stored? Are they stored in the kube API? Are they stored in the node 1, node 2, node 3, or node 4? That's what the function of the etcd server is. So it keeps those records, right? Has any question? Okay, all right. I'm going to move further, just to explain it more further. resource I want to talk more about now today, about now is nodes. What are Kubernetes? What are nodes in Kubernetes? Nodes is simply a server. It could be a physical machine, it could be a virtual machine, but it's literally the server that your Kubernetes is installed on. So for example, now, in my environment now, I can show you my environment now, which is basically virtual. If you have Docker desktop, like I advised you guys earlier, if you have Docker desktop, like I advised you guys earlier, you can spin up Kubernetes. This, if I do kubectl get nodes, this is a node, right? So it's basically saying, hey, you can see call the name Docker desktop. That is ready. Control plane available 83 days ago. Version of Kubernetes 4.1. It's basically saying so has a node, which is basically my laptop, and is running Kubernetes on it. That's what a node is, right? That's what a node is. Very simple. A node is basically a worker machine. So all your containers are basically available in what? In a node, right? In the past, it's also called minions, but nobody called it minions again. This is like the early days of Kubernetes, which is 2015, 2016. That's what they call minions, but nobody called it minions again. Right now, it's really referred as node. So for example, now, if I look at my environment now, I'm running what? A single node cluster, meaning that I'm running only one node in my environment. So if you go to production now, it's possible that you can't have a single node cluster because it's not highly available. You have multiple nodes in your environment, right? So please take note of that, right? The next thing I'm talking about is a cluster. Because a cluster, is a set of nodes together, just like I was explaining a minute ago, 3 seconds ago, rather. So right, helps you what in load sharing. So when I have node 1, node 2, node 3, it makes it become what? A cluster of nodes. It helps in high availability. The beauty about the cluster, which is a couple of nodes being inside it, is that if one node should fail, let's say I decided to update one node, all the services in that one node is going to move to the other nodes. That's the beauty of Kubernetes cluster. Having what? Multiple nodes. Someone can say, hey, so why didn't you have multiple nodes in your environment? Again, it's a lab environment. It's just something I'm using to test up a few things I'm working on, right? So it helps you work in load sharing for the cluster. So note, a node is basically a server or a VM that has what Kubernetes installed on it, right? Inside a node, if you have multiple nodes, you have what called a cluster. Ignore them. Kubernetes architecture. So in Kubernetes architecture, when you have, it's possible to have when you have multiple nodes, right? There's always need to have one that we call master. The master is like the Oga, right? It's like the Oga of the house. It's like the CEO. The job of the master is to receive all incoming traffic and direct them to the particular nodes. The kube scheduler I mentioned earlier, the kube control manager I mentioned earlier, the etcd server I mentioned earlier, they all live what? In the master node, right? It coordinates the activity that happens within the cluster. So things like provisioning nodes. So for example, if I want to add a new node to my environment now, it's the master that provisions that. If I want to schedule which container, which node to run a particular container pod rather, right? It basically is the master that does that. So it's a good thing to know. Say, hey, what does the master do? The master is, sorry, Don, can you mute? I'm muting you. Okay, all right. So basically the master node function is to manage the cluster. Sorry, guys. The master node function, the master node job is to manage the cluster. That's what his job is about. It's not to do anything else. It's basically to manage the cluster. That's the job of the master node. So the master node basically say, hey, Dominic wants to access the application. It hits the Kube API server. The master node basically say, which application is Dominic trying to access, which endpoint, which app, which port is hosting the application. Is the master node that handles that. Oh, this port is not starting. It tells the kube control manager, hey, please, this port is not starting. Can you restart it? Can you restart it? Because it's about enable. Oh, I want to run a deployment for a replica set, which we're going to see very soon. I want to run how many starts of a replica set. What's going to do that is the master node that is going to tell it what to do. literally. Okay. So guys, remember we started what with what. So from this now, the API server, the cube control manager, the HCD, which other one, cube scheduler, they all are installed or what on the master node, right? Right. Kubernetes components. I've got it a little bit. I say, okay, hey, I talked about the HCD. I say, hey, the HCD is basically what a key value store. How do I know that for nonso is running on node 3? What does it store? It's basically the database of the Kubernetes cluster. For the HCD, it's all about, right? I think I mentioned a little bit about the scheduler, the API server. Yeah, I mentioned a little bit about that. So go more into deep. Okay, what's the difference between a master and the other nodes? That's something we would like to know. Okay, what's the difference? In Kubernetes installation, the API server, the ATCD, Kubernetes service, container runtime, controllers and schedulers, they all run what? On the master. It's only the kubelet service that runs on the node. So if you look at this screen now, look at the screenshot. All these guys is what is really used to manage what in the node, the nodes. So the only thing that is installed on the node is the kubelets. So each node will have a kubelet and a container runtime. Before it used to be Docker, right? But it's no more Docker now. Now it's not container D, right? Now it's not container D. So the container runtime basic for Kubernetes now is literally container D, right? It still work the same way Docker work, right? But every node will have what must have what a kubelet installed on it. Must have a kubelet installed on it. That's the default. Okay. All right. I think I mentioned this one. No need to go over it. I say, hey, basically all things are stored what on key on all the database. All the actions are basically stored in the database called what the HCD server is basically key value store. The one thing I've not mentioned is key proxy. What's the function of the key proxy? The key proxy is for networking. So I believe when you guys ever heard the word proxy, basically networking, right? It's basically for networking. It's basically what is used to communicate between two environments, between two nodes. Don't know, guys. Like, can anybody hear a child screaming in the background? Can I hear any child screaming in the background? No.
No.
No. Okay. All right. Good. I have my first one singing up at the background. Sorry, guys. Okay. All right. So, Kube's proxy is basically used for traffic between the nodes and the cluster. So networking. Anytime you think about networking, when we go into Azure, we're going to talk about what we call CNI. Where we see whether hey, should I use Azure CNI overlay? Should I use only Azure CNI? What are they? We're going to look into that, which is what I'm going to cover next week. But this week is basically just about understanding Kubernetes very well. So guys, just try to understand these basics. Trust me, if you understand these basics, you have understood Kubernetes. All right. Forget about how to deploy. You can keep that with ChatGPT, all those ones. You can do your labs and everything, but understanding the basics, so you actually know what to ask, right? And what to troubleshoot. The next thing I want to talk about is YAML. Kubernetes YAML. Someone will say, hey, so what is Kubernetes YAML again? Kubernetes YAML is basically how we deploy to Kubernetes. So I want to deploy a Kubernetes resource. How do I deploy to Kubernetes? Is YAML. YAML. Yet, and the YAML stands for what? Sorry, that's 1 minute.
You said it 1 million times last week. So please don't Google. This is something that you need to put in your head right now.
So, guys, if I look at me as if I'm sorry for that brief in communication. Well, it might look as if I'm dumping a lot of things on you, but I'm just explaining them. So, for example, so when you Google and say, okay, hey, I want to create a pod, a YAML file, that creates a pod, or you put it out in ChatGPT, this is something you actually know what it's giving you. So, YAML starts for what? Yet another markup language. This is what you use to deploy resources in Kubernetes, right? I'm going to pause it here. It has several API versions. I don't want to go into that now. I want to talk about what we're going to deploy. At the end of the class, I'm going to share a video. So I believe if you have time during the week, just go ahead and watch it so you understand my YAML in detail, right? Again, another thing to look into concept is pod. What a pod? Pod is basically the smallest unit of object in a Kubernetes. The pod is basically a single instance of an application. So you guys remember how we talked about looking into containers, right? Last week we looked at containers. Dominic built a container, built an application in a container, right? That a container will be living inside what? A pod. So a pod is the smallest unit of an application. So I can write an application now, very beautiful application, Piper application. The application is used to Google the internet, is used to scrape the internet. Everything is doing. That application will be inside what? Pod. So a pod can have what? One or more containers. Like remember, pods, the smallest unit of anything you're deploying in Kubernetes, pod can have what? One or more containers. It's important to know this, right? Pod is basically where your applications are. So if I have 5 pods hosting my application, it means that what I have 5 instances of my application running in my environment. Okay? Please note this. Pod concepts. A pod can be created in 2 ways: imperative or declarative, right? Imperative is basically when you say, hey, kubectl, again, I'm not commands on you guys. That's why I say, please try to learn the basics here. kubectl run nginx image nginx. I'm basically saying, hey, kubectl run nginx with an image nginx. I'm basically saying the name of this pod is going to be nginx and the image is going to be nginx. I want to show this out. I don't want to just be talking about it. Let me clear. I want to clear my screen. So right now, I want to check, do I have any pod running? So kubectl is how how in Docker we use anything starts with Docker. Community with Kubernetes, everything starts with what? kubectl. They call it called kubectl. You see kubecontrol. Me, I prefer call it kubectl, right? kubectl, kubectl, kubecontrol is basically the same thing. It starts with what? kubectl. Then the next thing I'm going to do get. Get means, okay, hey, verb, right? Verb, get pod. I want to see, is there any pods running in this cluster? So it's basically say, hey, there are no pods found in the default namespace. I'm going to explain what namespace is that, or not yet. I'm going to look at kubectl get pods, basically saying, hey, there are no pods found in the default namespace. So right now, I want to create a pod in the imperative way. Imperative way, right? Imperative way basically say kubectl run. I'm going to name this pod nginx. I can call it nonso, but I'm going to name it nginx, right? I'm going to do image. It's asking me which image do I want to use, right? Which image do I want to use? You guys remember images? Remember containers? Remember image? Remember images? This is what it's asking me. Which image do I want to use? I'm going to say I want to use nginx. I can specify a particular tag, guys. Remember tags, but I don't want to specify that tags. Now, if you don't specify this, it's going to pull the latest. That's what I'm going to allow you to do. This guy telling me now, kubectl run nginx image nginx. This guy say pod nginx created. So guys, remember when I do kubectl get ports and I didn't get anything, I need to do kubectl get ports again to see whether I get anything. So using the up arrow not to type everything back, what's it showing me? Saying, hey, the name of my image is what? nginx. So the name of my pod is what Nginx, and the status is what running, and it has 0 restarts. So right now in my environment, I've created a pod named what named what QCTL. So I created a pod named Nginx. Sorry, not QCTL. I created a pod named Nginx with an image Nginx. I can create another pod name. Let me name it Piper. Piper. Run first of all. Run. Piper. Which image did I use now? I'm going to use Redis. Image Redis. If I press enter, saying created. If I do kubectl now, get pods. I've created 2 applications. You see what it's telling me now? It says, hey, one is running. Piper is still at 0, 1. Created, still created. It's not yet done. Let me check whether it's finished created. It's now running. Okay. Do a little bit of troubleshooting. If I want to see what image I used to create this Piper, right? Assuming I don't know, I want to see the image I used to create this Piper. I can do kubectl describe, like I see now. Instead of get, I'm trying to describe what I'm going to do pod. Then I'm going to say what Piper. This is a simple English. That's why I say if you understand it, just the simple. You don't need to. If you understand it, when you do a Google and you see, you understand what it is doing, right? I press enter now. I can see, okay, this is the description of what the pod Piper. Telling me the priority is 0, labels, no, only one label Piper. This is the IP. So it's telling me, hey, okay, full level, this is telling me the image ID is what? Redis, right? It's telling me the Redis is the image ID. That's the image I use. So it's basically giving me everything about this pod. No selectors, no selectors, toleration, no tolerations. All those things, you read out more about them, right? When you do your research. So this is what he's doing. He say, hey, default scheduler. Well, remember what I tell you guys, scheduler. Scheduler job is what to assign a pod, what a node. Queue scheduler. Because queue scheduler started immediately. I say, hey, I want to create a pod. The queue scheduler, they assign it to this node pod was Docker desktop, and what it's pulling the image ready, which is the image we specify. Remember, successfully pulled the image in this 10.316 seconds. It created the container and it started the container. These are the steps, right? These are the steps of what just happened in writing this. And remember, this is what the imperative way. This is the imperative way of creating. The declarative way is through YAML. So I'm going to bring up my VS Code here, and yeah, let me just drag my VS Code here and see. Let me see. I'm trying to get a miss of time, so quickly let me just grab trying to grab a simple Kubernetes this Kubernetes deployment. Okay, let me just grab a simple one. Right. This guy is simple. I'm going to name it. Let me call it which one should I use? We can do another Redis. Let me do Redis port. Let me do Redis port, right? Redis.yaml, right? YAML. Right. I'm going to paste this out, right? So this is what I was trying to explain to you guys before. This is what a YAML. The beauty about this, I'm trying to zoom. Is it clear? Can you guys all see this? Can we all see this clearly? Right. Okay.
Yes.
Yeah. Okay. So what am I doing here? I'm basically I'm trying to create or doing what the declarative way. Declarative way is mostly the way you are going to interact with Kubernetes. Most people are likely going to use declarative way because that's how you're going to have multiple instances of this. When we go to the next level, you basically see why declarative way is the way most people go, right? So what am I doing here? I'm creating what the API version is 1. The kind of resource I want to note is not this kind of resource I want to get is what pod. If it's a document, if it's not a pod, you're going to see that example, right? You're going to see that, but just hold on. The metadata name, I'm going to call it Redis. You can call this guy anything. So if you have a bunch of Redis applications running and you want to link it up, you can use this metadata and labels. You call it metadata and labels to basically link them together. The next thing I'm going to do, container, I'm going to spec. Spec is where you define the container. The name is Redis. I can call it Redis 2, because if I run this, it's going to fail because I already have Redis running. Already is Redis 2, and the image is what? Redis. So let me save this now. I'm going to try to deploy this. So I'm going to go to terminal. This is my terminal. I'm going to do kubectl apply -f and do what? Redis.yaml. So right now you see what that Redis created. So if I do kubectl get what? Pods, what do I see? I can see, okay, hey, I have Piper running. I have Redis, and the Redis running. You can see we just created what? A pod using what? Declarative and imperative way. Guys, any questions before I move forward? Any questions? Anything you don't understand? Anything you like me to explain more? Okay. Giving 5 seconds just to make sure we are all good. Vincent is typing. Okay. While Vincent is typing, so I'm going to move on to the next one. When the questions drop, I'm going to explain. Okay, so this is a simple lab on how to create Redis with using the imperative and declarative methods. I believe we've already done this lab. So do you guys have any questions before I move over to the next Kubernetes resource? Any questions? Okay, moving forward. Okay, the declarative way. Okay, once me to repeat the declarative way, let me just put up my VS Code again. So the basic structure, before I repeat it, I want to go a little bit back just to show you guys something. Right. This is the structure of a Kubernetes, basic structure of a Kubernetes YAML. Get another markup language. So YAML is not only attached to Kubernetes. If you ever written Ansible, most configuration things we use in DevOps are basically using YAML. It will make sense to know YAML. It makes sense to learn YAML. I'm going to share a video on how to learn YAML. But what the declarative way is basically a way for you to deploy resources. Each resource, this is the basic structure: API, kind, metadata, and spec. Right now, we are in the smallest one, which is basically a pod. So for a pod, API version here is going to be what? V1. The kind is going to be what? Pod. The metadata can be name, it can be non-so, it can be anything, it doesn't really matter. But the name and labels, you can identify those one because that's how you're going to use to communicate with other environments, right? That's it's total about. So example, to show you the simplest example is this one we created here. This is Redis. I want to switch from Redis to, let me use HTTPD. HTTPD. So I can call this one, name of the container HTTPD. Call image HTTPD, right? HTTPD. So if I save this now, let me save it to save as to make sure that, that I've just saved it again. But if I should let me do save as, sorry guys, save as and call it HTTPD. So this is HTTPD now. Remember, we are still in a pod. The API version, because your pod is V1. The kind, what kind of resource are you deploying? You are deploying what? A pod. The metadata is basically metadata just think about information that actually can be read by APIs. That's what metadata is all about, right? The spec, the containers, is where the spec container. So before I mentioned that it's possible to have more than one container running in a particular pod. Remember I mentioned it before. It's possible to have more than one container running in a particular pod. So in containers, you can have more than one container. You can have more than one container. You can have more than one container running in a particular pod. So, but here I'm basically deploying only one container. So I'm calling this HTTPD. I'm deploying HTTPD. I'm calling HTTPD. So I can come here and just say, okay, hey, start declaring this name is HTTPD, image name is HTTPD. Can now do kubectl. I know this is where apply -f means pause. Okay, apply this to this my declaration template, which is what httpd.yaml. If I press enter, it's going to be pod created. Going to be pod created, httpd created. So if I do kubectl now, get pods. You're going to see what HTTPD what is running. I want to try something. I want to have I want to have 2 containers running into this. So I'm going to try something. I'm going to add another container running into this, right? Take a look at this. When it's ready, you're seeing what? One of one. Meaning one container is ready, one container is running. One of one. One container is ready, one container is running. I want to have more than one container running a pod. So I'm going to come here and do something. I'm going to do that now one and do what? I want to add nginx, right? And do nginx, right? I'll now change the name to be, then we'll call it httpd nginx, right? Saving it, right? I'm going to apply it again. So that's the difference between declarative and imperative. Imperative, when you create it, there is no way for you to go and you can go and edit, yes, Kubernetes usually edit, but it's advised to use imperative in the sense that it's advised to use declarative, because with declarative, I can share this YAML with you, and when you run it, you better get the same experience. If I ask you, okay, if you write an application, I ask you, hey, can you give me the YAML file that you used to write this application? You can share the declarative to me, and when I run it on the environment, once I have access to the images, it's going to put this image and it's going to run. So this, for example, now I'm going to try to run this again. Remember, guys, kubectl apply -f httpd. That's the file. I'm going to press enter. It's going to create another one. So if you do kubectl now and you get pods, what do you see? You can see this one is still running, right? But what do you see here? kubectl nginx is creating. What do you see? 0 or 2 creating. Because of what? It's 2 containers living inside what? One pod. So I can do get pods again just to see. What do I see? Hey, one is running, one is erroring out. Let me clear. I want to clear my screen and let me bring up VS Code. Let me see. Why is it erroring out? So clear kubectl. Let me kubectl get pods again. Let me do kubectl get pods again. So one is erroring out, guys. Can you see? So let's see why is it erroring out. kubectl. I can't tell you what I should type next. Anybody there? Describe. I'm going to describe this pod. Describe this pod, right? Describe. What you saw am I describing? I'm describing a pod, and I'm going to put it, the name of that pod, and I press enter. So if I put it here, so what am I seeing? So again, we can look at the events that happen, called Kubernetes events. So it says successful, it's schedule again. Schedule it on this node Docker desktop. Full image HTTPD was successful, right? Started the container HTTPD. Full image this, started this, backing up, restarting, pulling image again, created container, started container, full image. So it keeps failing, right? If I do describe it again, you see that it's still backing off again, backing up, it's still failing. So if I clear screen, till get pods. Let me see. What can you see? Oh, right now it's running. See that self-healing part of Kubernetes I was trying to tell you guys about. So what do you see? For restart. So you keep restarting it, try restarting. So sometimes you have application running Kubernetes, that application might be failing, but you don't notice. But Kubernetes keeps trying to fix that, keep trying to restart the application. Of course, there's sometimes you try, you see crash loop. Let's say crash loop longer perpetual. Remember the full name, but crash loop. So basically, because in a loop, it's not going to fix it. It's not going to fix it, but it will continue trying to restart it. So if you do kubectl get pods and you see multiple restarts, let's say 20, 30, 40, sometimes 200 something, it means that something is definitely wrong with that pod, right? Maybe the pod is running out of space. Kubernetes keep trying to fix it. This is the self-healing part of the Kubernetes, right? You guys know what it's saying 2 or 2? It's basically saying that 2 containers and 2 what? This thing is running. 2 containers and 2 image and containers are running inside this 2 pod. Both of them are running. Remember when they were not running, what were you seeing? We are seeing only one of 2. Meaning one is running. Out of the 2 containers there, one is running, one is not running. Okay. Vincent, is it clear?
Yes, very clear. Thank you.
All right. Thank you. The next thing we're going to look at is what we call replica sets. replica set, replica sets. You remember how I say, hey, one of the beauty things about Kubernetes is able to deploy in multiple, you can have multiple instances of application as pods. But does it make sense? Look, imagine now, if you check this, guys, this thing I created now, I have what Nginx running here, HTTPD running here, this one. Imagine you're creating that instance of each application. How would they communicate? How they can communicate with metadata, but Kubernetes gives you a way to say, okay, I want my application, so application to have what multiple instances where replica sets comes in. Oh, Leo said he's on the waiting room.
Okay.
I can't find you here.
He has the
I
wrong
can't find him here.
Check if
Yeah, just please share. Yeah, maybe he has the wrong URL.
Somebody
Tell
should
him
share
to
that.
use this URL. Okay. All right. So guys, please just share the new link to you. I think he's using the old link. Okay. So what a replica set? Replica set is a way, it's another resource, just like a pod. A replica set is basically a way for you to create multiple instances of your application. The beauty about replica set is that replica set, if you use replica set, Kubernetes is going to ensure that at every instance you have 3 instances of your application running. If you say, hey, I want 3 instances, remember, just look at this guy example, say replica 3. Yeah, I want to have at every instance, I want to have 3 instances of this application running. So the beauty about it is that Kubernetes takes, I used to say Kubernetes buys market. Our people used to say buy market. You carry it on his head. So far you say, hey, I want to have 3 instances. Kubernetes to make sure that at every instance, a pod, 3 instances of those pods are running. That's what replica set is all about. Okay.
Also, let me just add up to what. Also in Kubernetes, you can do what they call. You can use what they call HPA. That is, it is called horizontal pod autoscaler. So let's say, for example, now you have a website like Jumia, and on Friday they are doing what do they call this thing that they do shopping, that they bring down the price?
Friday. Black Friday.
Black Friday, thank you. And let's say in Jumia, we have over 1 billion people log into that website, right? The essence of this HPA, that is horizontal autoscaler now, will when you host a website in a particular pod in Kubernetes, for example, and then people flooding that website, it will bring a lot of traffic and that site will go down. So the essence of horizontal autoscaler is to continue to bring replicas of different image where you will host the website. So it will give you options where, for example, if 1,000 people or 100,000 people are going to Jumia.com, for example, it will continue to stabilize because of the HPA horizontal pod autoscaler. It will continue to scale different instances where people will continue to use the website without having issues. Let's say, for example, now, so that's the essence of the beauty about Kubernetes, for example. So when it's talking about replica set, I'm trying to say that Kubernetes also have what they call horizontal pod autoscaler, where it scales the number of pod and replicas in a particular deployment, and they use what they call stateful or a stateful set or a replica set, for example, based on the services or being used in the Kubernetes. So what I'm trying to say in the essence is you can use Kubernetes to scale as much pods as you like. It will automatically scale those things without you going to add pods. Let's say you are using a website and your website is down because too many traffic. So Kubernetes will help you bring so many pods where you put replicas of your website in different pods, and people can log into the website without having issues of such. Thank you.
Okay. All right. So I'm going to give you an example of a replica set now, right? I'm going to paste. I will share this with you. I actually have it as part of the labs, but I'm going to share this with you. This example of a replica set declarative YAML. What is going to do here? I want you guys to note a few things. The API version is what? App v1. This one is what? v1. Again, don't try to cram this. You can see it in Google. Even the Kubernetes application that I've written, several Kubernetes applications, there's an option to go to documentation. You will see this, but just this is what makes it a replica set. The kind is what a replica set. The metadata is nginx, labeled this. I'm going to call this. All these guys are just part of the metadata. So I want to run 3 instances of what this application. So I'm going to call it just let me make it 5 instances. Guys, example, let me make 5 instances, 5, right? And do save. Mat labels front end, and let me front end, nginx. I'm going to leave it like this. So I'm going to apply this replica set, right? So again, on the terminal, I'll do kubectl apply -work f nginx rs. So it created this guy. So if I want to bring up this screen because I think the screen is bolder. kubectl get pod. What do you see? I missed an L. Clear screen. kubectl get what? Pod. What do you see? Something is off with this. This is keep restarting, but what do you see, guys? Can you see nginx this? They're all part of what? The replica set. Can do what? kubectl get what? Replica set. Can do get replica set, replica set. What do you see? nginx. The image name is what? nginx. That's what these guys are. That's why you have nginx. We have 1, 2, 3, 4, 5. So I want you guys to explain the guys. So just look at the names, right? Look at the names of this. You see the names D4, D. I want you guys to show you guys something. I want to try and delete one pod. I want to delete one pod. It's really the power of command. Let me delete the last one, right? Watch. kubectl delete pod this. You see, it's deleted now, right? If I do kubectl get pods again, what do you notice? It's created another one already. Because I tell it that the desired state is what? 5. It should always have 5 instances. So look at this at 5 instances of your application. That's the beauty of replica sets. Replica sets is basically used to define if you want to have multiple, if I want to have 3 instances of this application, and automatically, if anything should happen, somebody deletes a particular pod, delete a particular, then it will keep Kubernetes automatically will bring it back to the number 4 or not 1 to keep up that level. So you can scale down. I can come here and say, okay, this apply now, I'm going to make it instead of from 4 to 3 and save it. If I do apply again, what's going to happen? It's configured signal. Here it's created. Here it's also what configured declaratively. So if I do kubectl get pod now, you can see is reduced what to 3. That is no more this thing. If I do kubectl, let me clear screen. Sorry, just to. If I do let me get replica sets. What do you see? Name is still nginx. The desired was 3. We can have 3 instances running. That's what replica set is all about. Guys, is it clear? Hello?
Yes, please go ahead.
Okay, all right. Moving forward. Okay. So, sorry, I'm moving. The next thing I'm going to talk about is daemon sets, right? Someone will say, no, so these names are getting confusing. That's why I'm not telling it, right? Replica set, daemon set, they're all resources. That's why I started with pod. Pod is the smallest unit. After that, replica set, then daemon set. Daemon set is just very simple. Daemon set is basically used, hey, I want to have my pod, this pod that we are creating with replica sets and pods. I want to have it each at least one on every single node. Use what? With daemon sets. Right? So if I create a replica set, it's possible that all of them will be on one node. But if I want a situation whereby I want it to be shared on every node, I will use what? A daemon set. Someone said no. So give me an example of the ones that I use daemon sets. Anything that has to do with logging. Let's say, for example, I want to collect logs from my cluster. I'm running Elasticsearch. I want to monitor my cluster. I want to monitor this. And that's where I use daemon set because daemon set will make sure that a pod, at least one single instance of a pod is running on every node as daemon set. Is it clear, guys? I'll move forward. The next thing is deployment. Deployments. Deployments are basically the father of replica sets. So, for example, right now we are creating only pods. Replica set first came out before deployments. Right now we're creating only pods. If I want to package my whole application, say my application will have what pods, basically a replica set, and after that, basically a replica set has pods inside them, right? Let's say my application will have a pod one, and after having pod, it will have other things. It will have what we call a service that was going to expose my traffic. If it's going to have all this, I can create what we call a replica set, a deployment. A deployment is like the older brother of, or I would call it the new version of deployments, right? Of replica sets. That's what the deployment is all about. So think of it like this now. We started with what? A pod. Started a pod. We talk about replica sets. Replica sets. We talk about the demo sets. And now we're talking about deployments. Deployments basically seeks all resources, because inside the deployment you can have multiple other resources declared inside them. This is an example of a YAML definition that deploys a deployment. You can see again, API version is app v1. The kind now is no more replica sets. It's now what? Deployment. What is it doing now, right? We have nginx deployments, we have labels, all these guys have, and then we have not the containers. We are specified by tag, and we're container ports. Here we are just doing deployments. That's just the difference. So inside deployment, you still have ports. It's possible to have what's called a services inside deployment. I'm going to give you guys an example of a deployment again. If I bring up this, I can call it new file, nginx -deployment for YAML. Someone asked the question. Let me see. Okay, Dominic basically pasted something. Okay. All right. So deployments. Okay. I want to get the YAML file because typing it is going to waste us some time. Yeah. Okay. So this example of a deployment. So it's basically the same thing you see on the slides, right? This guy is going to create a deployment called what? Nginx. Let me just call it Redis. Let me call it Redis. Let me just call it Redis. Yeah. Redis. Call this Redis also. Redis, yeah. Redis. I'll just going to allow it to use latest. I'm not sure of latest there. Let's use latest tag. So container port, I can call it 5,000 if I want to, or 6,000. Right. To just make it to be run on the right. Or I can remove the ports. I don't need the ports to be honest. I can remove the ports. Right. These guys are not the only things you can do. There are more variables you can add to this. So, but this is the minimum it needs to run. So if I do kubectl apply now, kubectl apply -f, call it nginx deployment and run. Going to tell you what deployment app where this deployment created. So I want to come here because I can zoom in here and do kubectl. If I do kubectl now, get deployment. You can see I have a deployment of Redis deployment of 545 running. If I do kubectl get pods now, are you going to see, hey, can you see the Redis deployment running? They basically do the same thing. They basically do the same thing that this guy does, that replica set does. For example, if I decide to delete this guy now, remember this one. Just look at this one. This one ends with q srm. Like if I do kubectl delete pod, and run. If I run it now and I want to do kubectl get pods again, see it's still running on 5, but you see that the q, this one we are saying is no more there. The q9 srm is no more there. All right, no more there. That is deployments for you. It's basically doing the same thing that Redis is doing. Okay, guys, any questions? Any questions before we move to services? Okay. All right. I'm quickly going to go over services. Then after that, we can close for the day. So I see that people are getting tired. Let me just go over services. We'll do the rest next week, right? Okay. Kubernetes services. What Kubernetes services? You hosted the application. It's also like a pod, and Demon said, but it is like a Kubernetes resource. But you hosted the application. How do you ensure that people from the outside or services from the inside can access your application? That's that's where a Kubernetes service comes about. Community service, the whole job of Kubernetes service is to expose your application. The only thing it does. When you go to Kubernetes service, there are three types. There are three types, right? There are three types of Kubernetes services. There's what we call the cluster IP, which is the default one. What we call node port, and that's what we call the load balancer. Cluster IP. With cluster IP, your services is exposed only within your cluster. Not exposed outside of your cluster, only services within your cluster will access this service. Node port. Your service with node port, your service is basically your application or your service is basically exposed to a static node. So that means if I have 3 nodes and expose it to node B, is only exposed on node B. A load balancer is what you get in cloud services, in Azure, in GCP, in AWS. This way, when you set a service to be type load balancer, what happens is that automatically it will spin up a public IP for you, right? By default, public IP for you, and you can use that public IP to access your applications internally. That's what a load balancer does. Or type load balancer, that's basically what it does. So remember, Kubernetes service is basically used to expose your application outside of Kubernetes or within Kubernetes. You wrote an application, the application lives in pod. How do I access those applications? The resource that helps you to do that is what? Services. This is what the sample of a service looks like, right? You have an application name, a pod that is already running, called my service. The app selector name, you name my app. Once you run it, it's going to create, you can say, okay, hey, I want the port to be 80, exposed on port 80, but I also want to be able to access the target port. You should be targeting 9376. That's what it's all about, to be honest. By default, you can see here, I didn't select the type of service I'm selected. I didn't say whether cluster IP or node port or load balancer. So if you don't put only those options, you don't put any of those 3 options, it's going to select the default one, which is what? Cluster IP. Right? Let me see what I can get a lab example again for a Kubernetes service. Where is it? Guys, any questions? All right, so I'm going to create a service, for example, now. Select Nginx. I already created Nginx, so I'm going to create a new, call it Nginx -svc service, SVC, the YAML. Again, I'm doing declarative way. So few things to note before I go forward. See this selector, it's actually very important. This needs to match what you have. Service needs to match what you in this app selector. This is how we know. For example, if this that I created now, what do I call it? I call it what? I call it the matching tier. I call it front end. This guy, okay, I call it app is Nginx. So look at it now. App Nginx. This guy, see this line now, line 7 is going to try to match with line what? Line 6 here. This is how he knows this service is going to try to expose this application. That's what it's going to try to do. Right. So ensure they matches your deployment labels. So I'm going to just go to save this. I'm going to do kubectl again. Fly -f. I'm going to do what? Nginx SVC. A service has been created. Let me bring up this guy because it's bold. If I do clear, if I want to get the service, I can do kubectl get what? SVC or kubectl get what? Service. So it's telling me, hey, this service what it type of is what? Cluster IP. The port number, the IP address, internal IP address is this, and it's associated to port 80, blah 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 blah, 12 seconds ago. Right? If I do kubectl, if I want to edit it, I can do kubectl. This is going to spiral, but I want to show you guys edit SVC or service. Either you do SVC short.com or you do service in full. Service my service. Oh, sorry, I missed an R. My service. Basically opened on a notepad. So I'm going to drag that notepad here. It's going to show you here basically, hey, this is the notepad. This is the cluster IP. This is what it's running. This is what it's targeting. Sometimes you make a mistake, you didn't target the right port, you can actually come here and edit it. You didn't target the right app select, you can come here and edit it. That's basically what it's all about. So absolutely no changes made. That is Kubernetes service. Guys, any questions? I'd like to stop here because I feel like I'm bombarding you guys with a lot. I want to stop here and give open to questions. Okay, Vincent has a question. Vincent, please go ahead.
Yeah, thank you very much for this this class. I have a question about, you mentioned something about Kubernetes using the default runtime. The default container runtime is container D.
Container D, yeah.
Yeah, so I wanted to ask, does that affect if, for example, I'm running an application on Docker, using Docker, and I'm deploying it, does that affect anything?
No, it doesn't affect. So the reason it doesn't affect is the container D, even Podman, Docker, they all use the general container. There's a standard. You know how we do there's a standard that's basically maintained. So they all maintain that standard. So that's why most times I would say people just learn Docker. If you learn Docker, you can use container D, you can use Podman, you can use anyone, because they all use the general runtime. So the general container runtime, they are all running the same base of container runtime. So it's not going to affect it.
Okay. All right. Thank you.
Has any more questions? Wow. All right. Thank you all. Believe see you guys next week. And please, let's be on time. Said pod is in a node, but all the while we are using pod. You said pod is in a node, but all this while we are just using pod. Yes. So remember, node. Remember what a node is. A node is basically say a VM or a physical server. So yeah, in this case, I'm using my laptop. My laptop is a node. It's like a house. Pod is basically the people living inside that house, right? People living inside the house are pods. That's what they are. And it's still typing, so I'm waiting for him to finish. Yeah, remember I said a node. You should have multiple nodes in your cluster, multiple servers, because no multiple nodes basically what creates what cluster. Remember when I should get you can have node 1, node 2, node 3, and we can create a cluster. The beauty about it is if a particular node fails, you can just spin up another node. The services in that node will move to this roasting will move to another node. Resources in that node will move to another node. So it makes sense to have another node. So a union of multiple nodes, once you have a 2-node, 3-node, it makes it what a cluster. Yes, you can create multiple nodes. Basically mean multiple VMs or multiple physical servers. Add them to your Kubernetes cluster by installing what kubelet and container runtime on it. Makes it multiple. That's basically you can join it to your cluster. I'm still waiting for Vincent is typing, so let me see. Okay, okay, thanks. All right.
Speak.
Okay, yeah, he's done. I think it's good now. All right. So, guys, any more questions?
Yeah, I talked about HPA, horizontal pod autoscaler. So you can, once you use HPA, you can automatically create a different amount of pods for you. So you talk about replica sets, you can use the replica set to automatically add more running ports for nodes for you, thereabout. So the OSP and replica set work hand in hand together. Vicent.
Sorry, I didn't get that question. Can you repeat?
The HPA, that is horizontal pod autoscaler, right? You can automatically, once you use HPA in Kubernetes, it automatically add more pods for you. Let's say you set HPA to be 50, for example, and you have about 49 pods running, or 30 pods running. So if one of them, the more nodes, how do I put it? The more nodes that you ask for, or the more, as soon as your infrastructure continue to grow, the HPA will automatically create more nodes for you, and more pods for you rather, automatically, without you going to manually add pods to those to your infrastructure. So it will automatically add pods, just like we also explain replica sets.
Okay, noted. It's just that the confusion there was, I could remember because I wasn't like fully in the class because I was multitasking other things. So I heard you mention nodes, pods being in nodes, and we making use of nodes. So all this while making use of replicating multiple pods and the rest. So now that you explained, to me I thought the pod was where the virtual machine is. So now that you now explain that the node is like the virtual machine that you create multiple pods in, and you can actually like replicate the nodes so that you don't have downtime or whatever, like you said.
Yeah.
So now understand better now.
So that image I just shared is a complete overview of what Nonso has been talking about, the entirety of Kubernetes 101. So if you want to understand, you see the image I shared on the chat. It gives you the entirety of what you need to understand about Kubernetes. With that, you will understand the basics of Kubernetes itself. It's like saying what does a pod is. A pod is like the smallest unit that contains one or more containers, right? So the node is the computer itself. So a container is a lightweight executable software package that can run on any inside the pod itself. So you already explained all of that. You can look that image again, and then it gives you a complete overview of what you need to understand about Kubernetes itself, the entirety of Kubernetes, what he has been talking about. So the replica set is to maintain like a stable set of replica pods, right? That the replica set works hand in hand with HPA. So if you have an organization that your infrastructure is continuing to is growing time after time, a HPA work hand in hand with the replica set, which is horizontal pod autoscaler. It will autoscale it. Replica set, you know what a replica means? Bring the replica of a particular pod. So that's just it.
Okay, thank you. So sorry, I just have a question again. You mentioned of replica set, that is replicating or like multiplying pods, right?
Yeah, maintain a stable set of replicas of pods, of a particular pod. Yeah.
Yeah. Then the horizontal, you see, you mentioned
pod autoscaler.
The autoscaler is also for pods, right?
Yes, it will auto scale more pods for you.
Okay, in terms of like when you have larger
infrastructure.
Yeah, okay.
Yeah,
So
I use Black Friday, for example. If you have a website, for example, so you host your website and you have over 1 billion people, or let's say 300 million people log into that website. Do you know that it will pull a lot of traffic and then it will force your website to crash? Are you aware of that? So the help of Kubernetes will continue to create a replica of where your website is sitting. For example, it will create a replica of where your website is sitting, and then it will help you to stabilize your website so that it does not crash. 1 billion people can access it, and then nothing will happen to it. It's just like when you say, you know how many billions users go to google.com, uses Google every blessed day, right? So imagine we have about 7 billion people on the planet Earth, and let's say out of those 7 billion people, about 3 to 4 billion people uses Google. Yes or no? And you know, sometimes there are people who are continually logging into Google at the same time. It might be different time zones, but the same time at a go. And do you know what the essence of this Kubernetes does? It will help you to stabilize that website where the website is hosted, so that it will create more replica so that you have like a replica image of different port where your website sits, so that if there are too many traffic, it will if 10,000 people log into one website to that particular website, and then another 10,000 people try to log into that website, it will create another replica of that image of the website in another port, so that another 10,000 people can log into that website without knowing. So it will continue to create more replicas. The more your people are logging, the more traffic is the more traffic is creating, the more replicas will continue to create, so that it does not have crash the website itself.
You asked a question. Leo say, how do you auto-scale in Kubernetes? So, Leo, there are several ways. One is the method Dominic just explained, the horizontal port autoscaler. You basically auto-scale depending on the number of traffic that is hitting. Another way is what we call autoscale that be configured on the nodes. So think of example now. Horizontal autoscaler is going to increase the number of pods running. But at the time, you might run out of nodes because of memory. So you can enable auto-scaling also on the node. And that's when we come to Kubernetes, for example. That basically say, hey, automatic. That's when we come to manage Kubernetes, for example, like AKS, like GKS or EKS. What happens is automatically it will be adding additional node depending on number of traffic that is hitting your cluster. All right. We are going to look. I'm going to show you guys an example on how to automate that when we get to AKS. Okay.
Okay, so
has question. Yeah.
So the Black Friday thing is what I use to explain all of that, so that you understand what it is used for. So sometimes you ask yourself, how do 7 billion people on the earth log into imagine 3 billion people logging into a particular website? Won't it crash? Won't it put so much traffic on that website? So the help of Kubernetes is what is running in the background. You won't know, but those things actually work. So the more traffic it is creating, the more pods it will be adding nodes and putting replicate the website into those nodes and pods, so that more people can log into that website and do not crash the website itself. So sometimes most people, they host the website in a just small EC2 instance. Let's say a T3 medium, for example, and then they will be maybe give it like a 10 gig or so thereabout. After that time, when the traffic of that website get to a stage, it will crash. Remember when in Nigeria, when they were trying to do a job opening in custom thereabouts. I don't know if any of you remember in custom, right? So they opened the website for every Nigerian to log into that website and apply for that job. Now, what happened to that website? A lot of people were logging into that website to be able to try to apply for the job, put in the applications. Imagine we have over 200 million Nigerians. Let's say I would say about close to 20 to 30 million people log into that website. Yes. And what happened? The website crashed. So those website is not hosted in Kubernetes, for example. So maybe they just host it in a small EC2 instance, right? And they expect that people will not go into that website. So the more people flood into that website, it will pull traffic. And you know, when the traffic comes into play, you need the help of Kubernetes to function properly for you at this point in time. So I'm just giving an instance where replica set or HPA, which is horizontal pod autoscaler, comes into play. it creates more nodes and put the link of that website in those nodes and ports there, and then people continue to log into this website and it continue to look stable to you. Like, oh wow, the Google is so fast. Why is happening? 20,000 people can log into google.com at the same time, and it's stable. You're wondering what is going on in the background. That's what the HPA and replica set is, what is going on in the background if you don't know. So I'm just trying to put that into play. I don't know if I'm able to answer your question, Leo or Vincent. So I think now, so should we call it a wrap for today?
Yeah, let's call it a wrap for today. All right, guys.
Okay.
See you next week. Remember, it's 6 p.m., not 7 p.m. Thank you very much. Thank you. Have a lovely weekend.
Thanks all. Yeah. Bye.